The second source of pressure in a fluid is when we have pressure due to external force. Remember, I said previously that this is where we get the application of hydraulic systems, which are pretty common. You'll probably encounter a hydraulic system at some point in your career, whether a lift to lift a patient up, or a barber chair. I don't know if you go into barber school, I guess I don't think that you will. Nothing wrong with being a barber, but anyway, hydraulic systems are pretty common. We use them in our cars. We use them in a lot of different ways. I'll explain to you why they're so useful. But first, Pascal's principle is the guiding principle behind that. And it says that when pressure is applied to a fluid in a closed container, that pressure is felt throughout the container. Now, let me be a little more specific here. So when pressure is applied to an incompressible fluid, all right, when we talk about fluids, remember we said that fluids include liquids and gases. They include liquids and they include gases. Gases are compressible. Right? I can take a gas and I can apply a pressure to it and make it fill a smaller space. Liquids, on the other hand, are incompressible. So gases are compressible, liquids are incompressible. So if I have a fluid and I apply a pressure to it, it doesn't change the volume of the liquid. It also doesn't change the pressure of the liquid. Well, it doesn't change the volume of the liquid. Now, when I have a closed container, so let's say that I have a container like this, and there's a piston pushing down on it, and it's filled with some liquid, right? It doesn't work with gases because with gases, if I applied a pressure to this up here, it would just make the volume smaller. But if you have an incompressible liquid, what happens is that the pressure that is here is exerted on all sides of this container. All throughout the container, that pressure is felt. And it's the same pressure. It's you get whatever pressure is that you're applying to the piston is applied all throughout the container. There are lots of applications here. So the heart, for example, applies a pressure, and this pressure is felt throughout the body. That's why you can feel your pulse, right? I mean, you feel your pulse right now. That's not occurring in your wrist. If you feel your pulse, that's occurring in your chest. That's where that pressure originates. And so that's an application. A baby can push on its mother's bladder, and the mother feels like she has to go, to the bathroom because once you get a pressure of a fluid within your bladder, a certain pressure causes that urge. There are three different kinds of pressures when we're measuring them, and that is gauge pressure, atmospheric pressure, and absolute pressure. So gauge pressure is the pressure reading on a gauge. So if you imagine, say, your tire, and so if I imagine my tire and I put my gauge on here and I read 32 psi, pounds per square inch. By the way, that's approximately equal to 2 atmospheres. So my 32 pounds per square inch, that's my gauge pressure, and that's just the pressure reading that you get on a gauge. This is a differential pressure. That is, it's the difference between the pressure inside the tire and outside the tire, and it doesn't take into account the atmospheric pressure. We've already seen the atmospheric pressure, that's the pressure due to an atmosphere. And at sea level, that pressure is equal to 1 atmosphere. Absolute pressure is going to be the sum of those two. So absolute pressure will be equal to the sum of your gauge pressure plus your atmospheric pressure. And so, for example, in my tire, my absolute pressure is going to be that 2 atmospheres, or 32 psi, plus the 1 atmosphere that's already there. And so it's going to be a total absolute pressure of 3 atmospheres. So 3 different pressures. I have a video on just how you make gauges. Gauges are kind of interesting, and gauges are pretty important to you because you use gauges to measure pressure. And so I'll show you that video in the links.